Hello everyone and welcome back to FatalSec. In today's video, I am going to show you how to supercharge your reverse engineering workflow with artificial intelligence. No cloud, no internet, just pure local power. We will be using a cutting edge protocol called MCP that lets traditional disassemblers like Ghidra talk directly to locally hosted LLM models. Now, just a heads up, to run these models locally, you will need a fairly decent machine, at least 16 GB of RAM and a solid GPU to keep things smooth. If you have got the hardware, you are in for a seriously powerful upgrade to your reversing toolkit. So here's the big picture. We are going to enhance Ghidra, which is a powerful disassembler, by combining it with a locally hosted LLM through a protocol called MCP. Instead of sending queries directly from Ghidra, we will be using Open WebUI, which is a sleek front end for interacting with local models. This setup allows us to ask the AI questions about functions, pseudocode, and program behavior, all running entirely offline. Alright, let's dive into the setup process. It's a simple 3-step journey to get everything up and running. In the first step, we are going to download and install Ollama, which is the engine that runs our local LLMs. Second step is to set up Ghidra, which is our reverse engineering playground. In Ghidra, we will install an extension called GhidraMCP for AI-powered analysis. Then as a third step, we are going to install Open WebUI, which is a sleek interface just like ChatGPT, which allows you to chat with your local model. So let's start with step 1. To run a local LLM on your machine, we are going to use a tool called Ollama. Think of it as your own personal ChatGPT engine, but running entirely on your PC or laptop without any internet connection. There are other alternatives out there too, like LM Studio, Gen AI, and more. But for this video, we will stick with Ollama because it's simple, efficient, and works great with our setup. Let's head over to the official Ollama website, which is ollama.com. Link to all the tools and repositories which I'm going to show you in this video will be mentioned in the description box as well. So let's download the installer for Mac OS. So it's currently downloading. It's about 185 MB. Okay, so the download is finished. Let me quickly open my terminal and go into the directory where I keep all my tools handy, which is under documents tool. Now let me move the downloaded ollama.zip file from the downloads directory to here. And then to unzip it, we will use unzip command followed by the name of the file, which is ollama.darwin.zip. Enter. And once the extraction is completed, you will see ollama.app directory, right? This is the installation package using which we can install the Ollama. So to launch it from the terminal, we have open command followed by -a followed by the name Ollama. Enter. Okay, when you launch it for the first time, you will see this pop-up dialog. Just click open. Ollama works best when you run from the applications directory. Yes, it's optional. You can move it to the applications directory. Once you move it, then it will become visible under this applications section. Otherwise, you can choose to not move. I'm gonna choose do not move. And then it's just a GUI based installer. You just need to click next, click install, and it will install this Ollama command line tool. And it will ask for root permission. So you just have to enter your credentials. And once installed, it will ask you to run the first model, which is Llama 3.2. So this is the default model which Llama provides. However, you don't have to run this command. Simply click finish. Just keep in mind, no single model is perfect. It really depends on the use case and your own experience. So for now, I have skipped installing Llama 3 model because this model can take up a good chunk of disk space. Instead, based on my own testing, I have found that Qwen models by Alibaba performs better when it comes to understanding code, especially for reverse engineering tasks. So next, I will show you how to download and run the Qwen model using Ollama. Let's clear out this terminal. Yes, so you can test whether Ollama is installed properly or not by running this command in your terminal. If you get this usage output, it means that Ollama is installed correctly. Now, there's an amazing platform called Hugging Face. Let me show you how it looks like. It's like the GitHub for AI models. You will find tons of models here that you can download and run locally on your own machine. On the right hand side, you will notice a list of trending models. But if you want to explore everything that's available, just head over to this models section. Here you will find pretty much every open source model that's been made public. And we can also filter the model by name. So we are looking for Qwen model. Let's search for it. As soon as I typed Qwen, you see it started showing me the results for Qwen models. Now there are a lot of Qwen models which are being displayed. As a general rule, always try to go with the latest version. In this case, it's Qwen 3. And you will also notice there are several variants, each with different number of parameters. For example, this one has a massive 235 billion parameters, which is incredibly powerful, but it also demands serious hardware to run. Since we are planning to run models locally, I would recommend sticking with 8 billion parameter versions. They strike a good balance between performance and hardware requirements, making them much more practical for everyday reverse engineering tasks. Now, another important thing to keep in mind while downloading models is to look for the ones in GGUF format. Right, as you can see over here, this model is in GGUF. This stands for GPT Graph Unified Format. It's a newer, optimized format designed specifically for running LLMs efficiently on local machines using tools like Ollama. So let's further filter out our search query and look for GGUF models. Okay, so now all the models which are being listed, they are all in GGUF format, and like I explained, it's a good trade-off to choose 8 billion parameter version, and Qwen 3 is the latest one. So let's select this particular model, Qwen 3 8 billion GGUF. You can also see that it's updated just 10 days ago, and here it will show you all the details about the model. So if you are interested, you can go through all this detail. Now to download this model, let's navigate to File and Versions tab. Here you can find different variants of this model. At first, this might look confusing because it's important to understand this naming convention, as it tells a lot about the model. For instance, let's break down this Qwen 3 8BQ4KM.gguf model by its naming convention. Here, Qwen 3 8B means that it's a Qwen third generation model with 8 billion parameters. Then we have this Q4. This refers to the quantization level. Q4 means 4-bit quantization. This is lowest in size, fastest, but it's least accurate compared to other models. Then we have Qwen 3 8B Q5. Q5 means 5-bit quantization, which is a good trade-off. Similarly, we have Q6, which is 6-bit quantization, closer to full precision, but this is bigger in size. Now, depending on your hardware configuration, you can select the quantization. More the number of quantization, more powerful machine or hardware you will require. Then after this comes K_M or _0. These are different types of quantization. Let's not go too much in depth about these quantization types. All you have to understand is that K_M is the best balance in terms of load and performance. Then _K have good performance but slightly less efficient. So based on this, you can select your model. I am going to use Qwen 3 8B Q4KM because as per my hardware specification, this model will run efficiently. Now to download this model, you can navigate to use this model button, and here it will show you various options through which you can host this model. Like I said, you can use Ollama or Gen AI or LM Studio. It's up to you. For this setup, I am using Ollama. So let's click on it and it will show you this pop-up on how you can run this model in Ollama. All you have to do is run this command, Ollama run followed by the name of the model. Let's copy it and head back to the terminal and paste it. Now I am going to make a small change here. Instead of running this model directly, I will just download it using pull command. This will simply fetch the model and store it locally, making it available whenever you are ready to use it. So it's of size 5 GB and it's gonna take some time to get downloaded fully. I'm going to fast forward this section. Once the model is downloaded, we can see all the available models using Ollama list command. As of now, I have only downloaded this model Qwen 3, right? Similarly, you can download other models as well and they will be listed over here. Alright, so that wraps up the first step. We have successfully installed Ollama and downloaded our local LLM model. Now that our local LLM is ready to go, it's time to move on to the next step, which is setting up the Ghidra disassembler and installing the Ghidra MCP extension to enable AI-powered reverse engineering. I think Ghidra disassembler setup is quite straightforward, so I will quickly walk you through that. All you have to do is go to their official GitHub repository by National Security Agency, okay? And then to download the latest release, go to the releases section, and here it will show you the latest version. At the time of recording, the latest version is 11.3.2, and under the assets you can download this zip file. It's about 446 MB, so let's wait for it to get downloaded. Once downloaded, let me go back to the terminal, clear it out, and let me move the downloaded Ghidra from downloads directory to this directory where I have all the tools. Then to extract it, we can simply use unzip command followed by the Ghidra package name, which is Ghidra 11.3.2.zip. Enter. And once extracted, you will see a new directory created with the name Ghidra 11.3.2 underscore public. Let's go inside this directory, and before running, make sure you have Java installed because Ghidra requires Java environment for its execution. And to run, once inside the extracted Ghidra directory, you will see this Ghidra run executable, right? So you just have to launch this executable Ghidra run, enter, and it will open the Ghidra disassembler for you. Next, we are going to install a crucial component, which is an extension called GhidraMCP. It was originally developed by Laurie Kirk, and under this you will find GhidraMCP extension. But wait, we are not going to use this. Instead, I have found a more advanced fork that adds extra layer of functionality and even supports multiple Ghidra instances, which make it perfect for more complex workflows. So if you just Google GHYDRAMCP GitHub, you will find this repository, Star Song Consulting GhidraMCP, and you can see that it's forked from the original Laurie wired GhidraMCP extension, and it says that it is multi-headed MCP server for Ghidra disassembler. So basically what happens is that each time when we launch a Ghidra instance, the Ghidra MCP extension automatically assigns and exposes a unique TCP port for that session. This port acts as a communication endpoint for that specific Ghidra window. This allows multiple Ghidra instances to run in parallel, each communicating independently with the LLM through its own TCP port. So basically, this way you can run multiple reverse engineering sessions, interact with different binaries, send context specific questions to the LLM, all without overlap or conflict, right? So the TCP port acts like a gateway. It's how the external interface like Open WebUI or any other MCP compatible client connects to Ghidra, and all the requests which users generally ask, like what does this function do, can you rename variable based on the logic, summarize this block of pseudocode, are sent through this port. The LLM processes the request and sends the right answer back. The reason why I am explaining this is because it's important to understand the inner workings of the workflow. In case anything stopped working, this knowledge will come in handy. Okay, so let's download this plugin by going into the releases section, and here we will download this complete package, GhidraMCP complete version 2. Okay, so it was only 161 KB. Let's go back to the terminal, clear it out. Let me go back to my tools directory and move the downloaded GhidraMCP extension to this directory. And now all I have to do is unzip this package, and I am going to unzip it into GhidraMCP directory. Okay. Once extracted, you will see that a new directory is created with the name GhidraMCP. Let's go inside it, and inside this we have bridge mcp hydra.py, GhidraMCP.zip, then license and readme. So this zip file is the actual extension which we are going to install now in Ghidra. And to install this, let's go back to Ghidra window, and all we have to do is click on this file button and then click on install extensions. These are some default extensions come pre-installed with Ghidra package. So from here, to install your own custom extension, you have to click on this plus icon on top right corner of this window, and then go to the desired directory where you have the extension. In my case, it's under documents, tools, GhidraMCP directory, and here you can see the extracted zip file, which is of type Ghidra extension. Right now, just click OK. So if you see this pop up, it means that this extension is built for Ghidra version 11.3.1, and since we are using the latest version, which is 11.3.2, that's why it's saying that the extension version is not matched correctly. But we can ignore this warning and simply click on this install anyway. And once installed, it will show in this extensions window. Make sure that this checkbox is ticked, and when you click on this extension, here it will show you all the details about it. Okay, and to make sure extension works properly, it requires Ghidra to restart. Click OK. Let's close it manually. And now the extension is installed. Let's go back to the Ghidra directory and launch Ghidra again using /Ghidra run command. And to test that the extension is installed properly, let's open up any binary for analysis. Click yes for analyze. Leave all these options as it is, analyze. And to make sure that extension is properly configured with this binary, you have to click on this file button, go to configure, and in this configuration tool window, click on this developer configuration, and under this configure developer plugins, make sure that GhidraMCP plugin is visible and it's checked. Okay, so now our GhidraMCP extension is properly configured for this particular binary which is open in this Ghidra window. Similarly, we can open a new Ghidra window in which we can analyze a new binary, and the GhidraMCP extension will assign a new TCP port to that window. So this way we can interact with multiple Ghidra windows using the AI prompt, right? Now let's go back to the terminal and let's go back to GhidraMCP directory. So next we have this bridge mcp hydra.py, which is a Python script, listens to the TCP ports exposed by each Ghidra instance, and this acts as a communication bridge. So basically it takes the AI prompts coming from the external interface. In our case, we will be using Open WebUI, which is a ChatGPT like interface, which will allow us to enter AI prompts or our queries related to reverse engineering and forward them to the locally hosted LLM model. It then takes the model's response and deliver it back to Ghidra or Open WebUI. You can obviously use any other external entity in place of Open WebUI to interact with the model, but since it's a simple and user-friendly interface just like ChatGPT, I am going to use this. Alright, so that's the wrap up of the step 2. Now the third and final step is to install this Open WebUI interface. So this is their official GitHub repository, Open WebUI. As you can see, it's a user-friendly AI interface which supports Ollama, OpenAI, etc. Now there are multiple ways in which you can install this, and one way is to install it directly using pip, but for this you need to make sure that you are using Python version 3.11 to avoid any compatibility issues. Otherwise this will not work. Another option is to install it directly using Docker. This is the fastest way to install and configure Open WebUI without worrying about its dependencies and compatible Python version. On my machine, however, I have Python version 3.11, which should be compatible, and just to avoid installing another piece of tool which is Docker, I am going to install it via pip. For this, first I am going to activate my Python virtual environment which I have already created. In case you want to create your own, all you have to do is run this python 3-m venv, which stands for virtual environment, followed by the directory path where you want to create your virtual environment. Okay, and I am going to simply activate it using source followed by the path of my virtual environment, which is under root directory, followed by fatal sec virtual environment. And then to activate it, I have to select this activate, enter. And now let's install this Open WebUI using pip3 install Open WebUI, enter. Now this part might take a little while as Open WebUI needs to download all its required dependencies and packages. To keep things neat and concise, I will fast forward through this step. Alright, once the installation is done, we can simply start this Open WebUI server using this Open WebUI serve command. Enter. It will then download some files for it which are required to run this properly. And once all the required files are downloaded and loaded, you will see this message saying started server process. Once it's set up, we can access it via localhost. So let's go to the browser, open a new terminal, open a new tab and type localhost. By default, it gets hosted at 8080 port, enter. So for the first time when you launch it, it will ask you to create a new admin account. In this case, as I had already configured it previously, that's why it's asking me directly to sign into the Open Web UI interface. Here I am going to mention the email ID which I have used. Okay, and once logged in, it will then take us to the landing page, which looks very much similar to ChatGPT, right? On the top left corner, you can see the model which we have already downloaded in Ollama, right? So if you have multiple models downloaded in Ollama, all of them will be listed over here. Currently, it's showing these two models. This one comes by default with Open Web UI, which is a general purpose model. And this is the one which we have downloaded, Qwen 8 billion, right? So from here, you can select the model which you want to use. Then here on the landing page, we have this prompt where you can ask your questions and it will be answered by the model you have selected from here. All right, cool. Now there's just one last bit of configuration left, and after that we will be all set to kick off some AI powered reverse engineering. By default, Open Web UI doesn't know how to communicate with the GhidraMCP extension. So if you ask question right now, it will go straight to the LLM, and while you will get a response, it won't be based on the context of the binary which is currently open in Ghidra. So to fix this, we need to go to the settings from the left navigation pane. Okay. Then under settings, we have to go to this tools section, and here we need to connect it to the bridge, which is responsible for communicating between Ghidra and LLM models. But for this, we first need to run that bridge MCP script, which we saw in the Ghidra MCP extension package, right? So let's go back to the terminal. So over here now we have this Open Web UI server running. Let's open a new tab. Here we have this bridge script. Now before we run this script, we need to install few dependencies. So this Ghidra MCP extension provide us with a nice readme file. Let's see its contents. Ghidra MCP is a powerful bridge, blah, 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 blah. Modular Ghidra plugin, the architecture enable AI assistant, features, advanced program analysis. Okay, installation, prerequisite, Ghidra, Python 3 should be installed. That's how we have installed the Ghidra MCP extension. Then MCP clients. Okay, so here, look at this note. It says that we can run this script directly using Python, but then we need to install these dependencies manually using pip. However, instead of running this script directly via Python, I would recommend to use UV. For those who don't know, UV is a fast and modern Python package manager written in Rust. Basically, it creates isolated environments and runs script with better dependency handling, which is perfect for cleanly managing the bridges environment. So this is the official GitHub repository of this UV package. And to install it, all you have to do is either install it using this curl installation script through this pip command. Up to you. I am going to use this curl command for now. So let me just clear this out, paste this curl installation script, enter. And it's downloading this UV package. Installing, everything's installed. Alright, now let's run it using uv followed by run command followed by the script name, which is GhidraMCP hydra.py, right? Enter. And here it says that it's connected to Ghidra plugin version 2 beta 4, which is exactly what we have installed in the Ghidra extension, right? However, there's one issue. Open WebUI still does not know how to access this bridge. While the bridge is now connected to the Ghidra extension, it can interact with the Ghidra instances or the Ghidra windows which are open, but we still need to expose this bridge to the outside world so that external tools like Open WebUI can communicate with it. For that purpose, we have to install another dependency or a tool called MCPO. This can expose any MCP tool as an OpenAI compatible HTTP server. So let me just terminate this script. And to install this MCPO, we can do it directly using pip3 install MCPO. Enter. And once installed, all we have to do now is to run this bridge using this MCPO reverse proxy, which will expose this bridge to the external world and allows Open WebUI to interact with Ghidra and locally hosted LLM model. Let me just clear the terminal, and in order to run it, we have this command uvx followed by mcpo, which is going to expose this bridge interface, followed by uv run, then the script name, which is GhidraMCP hydra.py. Hit enter. As you see, it automatically installed all the dependencies which is required by the script and the reverse proxy, and it's running and listening from all the interfaces on this 8000 port. So basically what is happening now is that this bridge interface is running and it's exposed to the external world using this MCPO reverse proxy at 8000 port, right? So in order to access this bridge from the external world, all we have to do is hit this URL with this port. That's it. So let's go back to Open WebUI settings page. Under tools, click on this add connection, and here in the URL we have to pass this URL where bridge interface is exposed, which is http localhost 8000, right? Click save and it will show you this setting saved successfully message. This means that Open WebUI is successfully connected to this bridge. Okay, and once connected, in the prompt here you will see this gear icon which says one available tool, and when you click on it, it will show you GhidraMCP server, and if you click on it, it will show you all the available functions which the tool is capable of doing. Alright, so the setup is pretty much done. Let's now try to ask something. In Ghidra, we have this binary open Flappy Bird, right? Let's ask AI to list down all the functions present in this binary just to be sure that everything is working as expected. So if we go back to Open WebUI interface in this AI prompt, let me just put in a query which says list down all the functions. Enter. This might take a bit of time since the model is running locally, so the response speed largely depends on your machine's processing capabilities, especially the CPU and the GPU. Alright, it's thinking now. Here it also shows you which function it has used to interact with Ghidra. Alright, so after almost 1 minute or 2 minutes, we are now getting the response where it's listing down all the function names which it has identified from the Ghidra disassembler. Awesome. This means that our setup is working, and in the logs you can see which API it has used to interact with the GhidraMCP extension. Awesome. If you are getting this output, it means that everything is configured correctly and all the components are interacting with each other as expected. Now you can start exploring and use the power of AI to reverse engineer any binary with this setup. In the upcoming videos, I will show you how to take this even further using AI to speed up analysis, understand complex code, and much more. So make sure to hit that subscribe button and stay tuned for what's coming next.